B starts moving in anti-clockwise direction in the plane so that the wire remains tight during the motion. Draw locus of point B. So to draw the curve, actually you must be able to visualize that motion of wire AB. I'll help you to visualize the motion. This is the given diagram. Here it is a disc. This is the wire in given position. End is fixed and end B starts moving in anti-clockwise direction. So this is how that wire will rotate, but it will come in contact with the corner of the disc. Then at corner A, wire will bend and it will start rotating about corner A. During this part of the motion also, this moving length of the wire in motion remains the same. Moving length of the wire, its length does not change in this. So from initial position of point B to first position of point B, it will be arc of a circle. From first position of point B to second position of point B, again it is arc of a circle of smaller radius. But throughout this motion from position B1 to position B2, throughout this motion, radius remains the same. So it is a portion of a circle. But now note here, wire is tangent to the semicircular edge. And now as this point B continues to move, now check here, free length of the wire continuously reduces. And this is final tangent at this end of the circular edge. Tangent at this end of semicircular edge. And after that again it will be a rotation about this corner. The first position of the wire tangent to the semicircle, that is this position, tangent to the semicircle. To the last position of the wire tangent to the semicircle. Here it is involute. So this is what we are going to draw to the scale now. So what I told you here, first visualize motion of the wire AB and now you proceed. Draw the semicircle of radius 25 mm. It is a semicircle, no, it is semicircular plate and therefore it has one more edge, that is straight edge. I have labeled that straight edge as CD. Then measure these dimensions, given dimensions, 12 mm vertically along the center line. At distance 12 mm from the diameter, draw a straight line, that is what is given in the problem. And then from center line you measure 12 mm to draw line AB. End A is fixed and end B starts moving. Measure carefully 135 mm but insert dimensions after completing the drawing. We divide circle in 8 parts. So we divide semicircle in 4 parts. So as usual, I measured 45 degrees and I got 4 parts of the circle. Now it is anti-clockwise motion. But yet winding action is not started. Check here. So this is first position. When end B will start, when end B start moving, it is first position of the wire. Then wire bends at point C and this is first position just before winding starts. So this is that first tangent at point C. Then a tangent. At all these points, as usual, you draw the tangent, use a roller. So when you set roller with this line and roll it, here at this point you will able to draw tangent. Set roller with this diameter, roll it, you will able to draw tangent here. Set roller with this line, roll it and you will able to draw tangent here. Set roller with this vertical center line, roll it and you will able to draw tangent here. Now, point A is fixed. Take distance AB in compass and A as the center, simply draw an arc. I have labeled this point as BA because for point B to point BA, for this point, I have used A as the center. But from this point onwards, center of rotation will change. It will become C. So take this distance compass CB. Take distance CB in compass and same point C as a center. You draw arc of a circle again up to the first tangent to the circle. This line is tangent to the circle. And when line becomes tangent to the circle or the semicircle, winding action starts. So from this position onwards winding action starts. So we should use the procedure which we have used earlier. How much length of the wire will get winded over semicircle? Equal to semicircumference. That is why, because it is a semicircle and how much length gets winded over semicircle? It's semicircumference. So it's not pi d, but pi d by 2. Pi d by 2, you should divide it in 4 parts. We divide pi d in 8 parts. Here we are going to divide pi d by 2 in 4 parts. So this is initial position for the involute of that semicircle. So we'll proceed on this line. We'll measure pi d by 2. Pi d by 2, 79 millimeters. Calculate, use calculator. Calculate pi d by 2. That is pi r, 79 millimeter. Then use our regular procedure. Check here. We should divide it in 4 parts. Now this end of 4th division you join with not BC, end of 4th division you join with end of pi d by 2. Remember, it's not CB you are going to divide in 8 parts, you are dividing pi d by 2 in 8 parts, this 79 millimeter distance in 8 parts. And use regular procedure to divide it in 12 parts. To divide it in 4 parts. Now, from this tangent point, you label the points on the tangent. Check here. 1, 2, 3, 4. Logic. What is logic behind that? When you start, when you continue with the curve, this point 1 comes in contact with point 1 here. And this much portion of the wire comes in contact, means gets wound over this circle. So now take distance 1 BC in compass, and that is length of first tangent. I have labeled that point as B1. Then take distance 2B in compass, and that is length of second tangent. Then take distance 3B in compass, and that is length of third tangent. Now take distance 4B in compass, and that is length of fourth tangent. From point C to point 4, that 79 millimeter distance, that is half of pi d distance, gets wound over the circumference. And the small distance 4B is yet free. So we should further move the wire or end B. But now, like this first two portion, here also D point as center, D point and point 4 are the same. D point as the center, you simply draw an arc. So these are the 3 arcs of circles that you can draw directly using compass. But middle portion you will have to draw freehand. And this is how you have completed the drawing. Now watch the drawing very carefully. The semicircular pleat, it is object involved here. The wire, so wire is dark, and you are asked to draw path of end B. So path of end B is dark. After completing the drawing, you should insert all these dimensions, 12 millimeters, 12 millimeters, 25 radius. Remember, when it is portion of a circle, you should always insert a radius. So insert this dimension, this given dimension 135. Also you should insert this dimension C4 as pi d by 2, 79 millimeter. So all dimensions which you have used in the construction, you should insert in the diagram. Read this problem. A fixed regular hexagonal plate of sides 25 millimeter has one of its longer diagonals vertical. One end of an inelastic thread of 150 millimeter length is attached to the lowest corner of the plate. If initially the thread is horizontal and it rotates in the plane of the plate so that it gets winded tightly over the periphery of the plate, then trace path of the other end. It is a fixed regular hexagonal plate of sides 25. Has one of its longer diagonals vertical. So first of all, in the given position, let's draw this hexagonal plate. Now to draw hexagon, first of all, you will have to draw circle of radius equal to length of side of the hexagon. Now it is regular hexagon of sides 25 millimeter long. So use the length of the side of hexagon as a radius and draw a circle. Don't draw this circle dark. Check here. Anywhere there is circular plate or circle mentioned in the problem? No. So there is no circle. So why we have drawn the circle? It is construction. Why we have drawn this circle? To construct a hexagon. So this circle is construction work, construction line. It must be thin or faint. Okay. Now, you want longer diagonal vertical. So when you want a longer diagonal vertical, from ends of vertical diameter, you cut the circle. If you want a longer diagonal horizontal, then use horizontal diameter. From end of vertical diameter, you cut the circle on both the sides. So that means on this side also. And what radius you have taken in the compass? Same as the radius of this circle. Similarly, as I told you, from both ends of the vertical diameter, you cut circle on both the sides. And now join these points and you get the regular hexagon. And check here, there is hexagonal plate in the problem. So I made that hexagonal plate dark. Don't make circle dark. Now try to understand. When you join opposite corners, of the hexagon, you get a longer diagonal. Now when you join this corner and this corner, you get longer diagonal, but not adjacent corner or not directly opposite corner, but on some other corner you get shorter diagonal. So this is longer diagonal, and from this corner, when you join this corner, you get a shorter diagonal. Similarly, there is one more shorter diagonal here. So from each corner, there is one longer diagonal and two shorter diagonals in case of a hexagon. Okay, so longer diagonal vertical. Check here, longer diagonal vertical. One end of an inelastic thread of 150 mm length is attached to the lowest corner of the plate. So lowest corner of the plate, there is 150 mm long inelastic cord. So I have drawn that inelastic cord. If initially the thread is horizontal, that is mentioned in the problem, that's why I have drawn it horizontal. If initially the thread is horizontal and it rotates in the plane of the plate so that it gets winded tightly over the periphery of the plate, then trace path of the other end. One end is in contact with the lowest corner of the plate. The other end moves and trace path. Visualize that winding action. So this is initial position. Wire will rotate directly about point A. This portion of the wire comes in contact with the edge, and remaining portion of the wire starts rotating about point 1, and the wire comes in contact with edge 1, 2. So from all these points, draw lines along the corresponding edges in this manner, and then simply use compass. Point A as center of rotation. Check here. Point A as center and AB as radius. Directly draw arc of a circle, so that here you get point B1. Then check here, 1 as the center. Draw an arc with reduced radius. Now 2 as the center and this as radius. Draw an arc. Now check here. This is how you simply, in no time you will be able to draw that curve. And finally point B comes in contact with this corner. Because this length, if you check it, 150 mm. So length of each side is 25 mm. 25 into 6, that is perimeter of this hexagon. So how much length of the wire gets winded over that? 25 into 6, 150, and that is the exact length of the wire. And when you draw these arcs, these are all arcs of circle. All these arcs, when you draw it, directly draw dark. So this is how that curve will get created automatically. So this is how we have completed the curve. Now what is the name of the curve? Remember, it's not involute. But there is a term used for this, involute of a hexagon. Not true involute. It is involute of a hexagon. So this is how you can draw involute of a square, involute of a triangle, or involute of any other shape. Insert all given dimensions. 150 mm length of the wire and 25 mm length of the edges. You have watched this video till end now, but most important thing is to construct these diagrams yourself. So run the video, pause the video wherever it is required, and follow the procedure as I have explained you. Thank you.